I just love it when a plan comes together. Oh, been doing some work on the old $7,000 mistake. Here's that little ring that I've been talking about, all ready to go back in the machine. And after a false start, that one's perfect. This one is a 1/2 thousandths too small on the inner diameter. But me and Bob took care of that. Bob's my 1973 Chucker lathe. Looks good, doesn't it? Didn't have to spray weld it. Guys, you guys are driving me crazy about spray welding. This is a precision shaft, not a shaft, I'm sorry, you're doing the same thing. It's a precision spindle. Now, how much precision is left in it after however many years it's been in use, I don't know. But I sure as hell ain't going to go and make it worse by spray welding it. Christ's sakes. I only needed this little bitty area right here. 3/8 of an inch. It's got 1.5 inches of bearing surface, and only 3/8 of an inch are unsupported on this spindle. So, I took one viewer's advice and got out some bearing bronze that I had. It's almost perfect. Put it on. Took another viewer's advice and found me some 640 Loctite sleeve retaining compound. It was made for it. Did a perfect slide fit up here. A perfect OD diameter. I even put it into the bearings, made sure it fit there, ended up polishing it. Good as new. Well, almost as good as new. About as good as it's going to get around here. And I don't know how much Monarch would charge for a new spindle, but I got a feeling it's up pretty plenty. I wouldn't be surprised at $20,000. Anyway, we're ready to move on to the next step. That's it for the Cliff Notes or the TikTok version of this video. Stick around if you want to see how I did it. I'd appreciate it. Thanks to all the new subscribers. Means a lot to an old guy. I'm just going to sit here and stare at it a while. Oh. Gotta love it when a plan comes together. Hey folks, welcome back. I'm kind of doing this a little bit out of order because there's a lot of interest in trying to get this spindle, not a shaft, a spindle, to where it'll accept the second bearing race in this Monarch 10EE. Now, let me clear up a few things. First off, that isn't a mole, it's a scab. I put an old welding helmet out in my truck one day and the sweatband had fallen off and it skinned me alive right there. It's taken a long time to heal it all back and grow the new skin. But it's getting there, and thanks for your concern. It's not a mole. In fact, the heart doctor saw me. He says, "We got to get that looked at." Okay. Anyway, back to this problem. I've decided to go ahead and make a sleeve to fit onto the spindle of the Monarch 10EE. It's only going to be 3/8 of an inch long. Now, I'm not going to heat that spindle. I'm not going to spray weld it to make an extension this long on a, God, I don't know how much it costs. It could cost $10,000 or more from Monarch. Probably more. If I heat that spindle up that spindle was ground to a tolerance of 50 millionth. Heck, I don't know, it might have been one of the 30 millionth. There is just no way. The back outside or outboard bearing is still going to be supported on that spindle by 3/8 of an inch of the spindle shaft. The front bearing's got 3/4. So out of 1.5 inches, I've got 1 1/8 of bearing surface on those two bearings. That should be fine. It's captured. It won't go anywhere. But I just want to make it a little better. So I've decided to make a sleeve. Now, you viewers help me out a lot of times. Thank you. One person mentioned that, well, you don't want to use stainless steel because it'll gall. Well, it's not being threaded in any way. It's going to be a slip fit onto it, maybe just a light press fitting. So I don't ever see me taking this sucker out of there. In fact, even if it were to gall, you could take a little saw and just cut that band off. It's not very thick, and peel it right off. I think stainless steel would be fine. But another person suggested bronze bearing material. It just so happens that I got up out of my chair at 1 o'clock last night and went out and started looking through all my stuff. And I found this little piece of bronze bearing material that is perfect. It's almost ready size right here. I just got to bore it out to fit the shaft and then turn down the outside. I only need 3/8 of an inch, guys. Then there seems to be a lot of discussion about how to attach that sleeve to the shaft. I was just going to use some green Loctite or red Loctite. I figured that would be pretty bad. That red Loctite, it takes heat to get it off. But one of the viewers suggested a Loctite product that I had never seen before, and it's 4 sleeves. So I went online and ordered some last night. It's on its way. Should be here tomorrow. So I've got the bronze bearing material that I'm going to use. And once again, guys, I know A-Bomb does a lot of spray welding onto shafts. This isn't a shaft. This is a precision spindle. If I were to heat that spindle up, I destroy the accuracy of it right off the bat. And there's no way I'm going to do that because that was a gift from the heavens. So I'm not spray welding anything. Get that out of your head. I'm surprised Don didn't put you up to this. Anyway, I got old Bob out, and for the new viewers, Bob is the 1973 Hardinge HC Chucker precision lathe. I bought this thing last year, and frankly, there's not much demand or call for HC Chucker lathes, so they're cheap. I bought this one from a machinist that bought it brand new. I've got the bill of sale for it. Got all the tooling and everything. I went and bought a automatic threading unit for it. And I haven't finished this because I got to take it back off. There's a plate right here that had to be mounted, and one of the viewers was correct and said I had it on backwards. Well, I just haven't had the heart to take it all apart to change it around, so other things have been more pressing. So here we go. I originally was trying to turn down a piece of that stainless 303 stainless, and then it got a nice surface finish on it, but I couldn't get it to break a chip for anything. I was taking 50 thousandths cut off of that thing and still was bird nesting everywhere. So I got to looking around, and I believe this is 4140 steel. I hadn't done a spark test on it, but That's what they usually are when I get them. And I'm going to go ahead and turn this down to make a go no go gauge for the bronze sleeve that I'm making. So y'all welcome to hang around and watch Bob at work. Oh, Bob is named Bob. B-O-B. Because some of you guys are arguing about the pronunciation of the manufacturer's name. Now, I think I know how it's pronounced, and they think they know how it's pronounced. I just don't want any more arguments. I'm getting old enough that I don't want to hear the bickering going on. So, it's Bob. I've got to bring this outer diameter down. Go ahead and face it off here and then cut that down. I stuck it on there just to clean it up, see what it looked like underneath. There's no pitting or anything. Of course, I'm just trying to get a fit on it. So you guys, I'm going to move you back out of the way a little bit and zoom you in a little bit. How's that? Okay? All right. For those of you that don't know what an HC Chucker is, it doesn't have a tailstock. So you can't do very long things on it because you got to be able to get the tool to come over to the outside. So you use different things on this rotary turret. I've always wanted a turret lathe my entire life. I've always been tired of changing tools left and right. So this takes care of it. Bob doesn't have a lead screw. You can't thread on it like a normal lathe. Another model of it does have a lead screw, but everything is controlled by an electric motor down here. Okay. This machine is made for production. Got all kinds of little doodads you can use. This locks the longitudinal feed, and let's see what we can do here. We'll turn it. I like it. Just cleaning up the face so no vibration, so I can get a really good cut. That's fine. All right. You can see here I took a start cut on it, and got to clean that surface up. But to do so, it's pretty easy. All you got to do is pull the handle, rotate the right tool into place, lock it in place, pull it out over here, switch the feed to the left, touch off, and go to it. I've got to be careful because I don't have a lot of material to work with. 75 and 4, so that's 875, 879. This is the flat belt sleeve pulley that drives the thing. It's on that same size shaft. I don't know why I'm being so anal about this. It's just a spacer. So damn used to running a lathe with a switch down here 34 years. It ain't there. Somebody took it. They moved it over here, which I really like. On a bob, you got forward and reverse, and then 1, 2, and 3 speed, and then you change the speeds up here. So you can go from 1, 2 to 3 all day long without messing around. Even better when I put a new cork on the brake. What am I looking for? Check this on that machine. Take another half thou. Eight, 7, 5, 876, and 8/10. 8/76 and 8/10. 2/10. This is going to be tricky. Spring pass in reverse. Double check it, but I think it's about 1/10 over. Perfect. Now, this fits snugly on this right now. This is going to be my go no-go gauge. I like it. Taking off about 50 thousandths at a time. This is the joy of a chucker. Change tools in an instant. want to get too far ahead of myself. What happened last night? I want to see better over here too. Now, I use this instrument just for the rough stuff. We'll get down to the nitty gritty. The mics come out. 187, 1870. Shit, did I go too far? Oh, I knew it was close. I did. See how easy it can get away from you? Too much. All right. Let's go to now. Let's go back and get that set up. a look. Now this is oil impregnated bronze bearing material, but we're just about going to be driving all the oil out of it when we get down into that ring. So I'm going to also put it in some solvent so I get the rest of it out so the Loctite will stick. Okay, the outside is it 2197, so we about 200 thousandths before we get into worrying territory. And 181.40. So we have 61 thousandths left on the inside. I'm going to whittle off some of the outside first. Then we're going to let it cool.
Two.
Well, hopefully you can hear me okay. Wind's picked up around here, and the three-phase 10 horsepower motors running in the other shop. Those old metal walls really transmit noise. I'll let this cool for quite a while. Take some rough dimensions and see where we are. The OD, we are at 2.106. Says I have 138 thousandths to go. Well, And I'm only doing this just to get it rough. When we get into the nitty gritty, we're going to go to a different way. That says I have 50 left to go on the inside diameter. So I'll tell you what I'm going to do. Last night I got greedy. I took a lot. Normally I'd take what I have and split it down into two, but I ain't going to do that. I'm going to take off 15 and then double check my measurements. In fact, I'm going to go ahead and do a spring pass on it. Hell, I might just do another one. I'm going to let it roll coming out. Pretty cool. Says I need to take 22 thousandths off. So let's go down to 10. There we go. Reverse it out. Spring pass here. this exciting. Just trying to not screw up again. Should be 4. Bring it out. We'll let it cool off for a while. And the last reading says I need to take off 1,000. First thing I'm going to do is take the spring pass again. See what's happening. Actually took a little bit off of that one. I'm going to vary my rate a little bit and go in. That's at about a half a thou. So I wonder what another spring pass would do. It's sitting there rubbing when it stops. That will give a slight press fit. I mean, slight. All right, let's work on the outside. I'm happy with the inside. So, let's go to the left on the drive. I don't know if I ever showed you guys this. This is Bob's drive mechanism. Now, if you notice, Bob doesn't have any lead screws or anything. This table is all driven by the electric motor. It's back here on the top and controlled by this. Left, right, and then you can control the feet. This machine can't thread like a normal lathe, so it has to go up here to the automatic threader, but then you can only thread about this far. The best of both worlds would be to have this one in an HLV that does have a threading gear, but I haven't found a decent one of those around, and that's what the Monarch 10E is going to do. So let's get to it. Sorry, the compressor's on now. It's everything. 975 plus 9. I have to take off 13.1 or 15 thousandths. We're just going to take it off real slow. We're going to take off 7 from where that is. 6, 7. Turning Bob to the left-hand side. It's down here to turn it on. Back it out. I'm going to vary the speed. That way you're not threading, you know, on your surface finish. You change the speed and direction so it's not following in the same groove all the way down.
97 plus 24, 950, that's 974. And 5/10. Really close. The inside is perfect, just a tiny slight press fit. The outside needs a half a thou to be perfect. And the problem running this thing is if I make the inside too big, as it's press fit on, it'll expand the outside. Really don't have a way to measure that, and once I get this stuck on there, yeah, I have to start all over if it's too much. So I'm going to depend on the Loctite sleeve retaining compound to do its job as it's on the shaft. It's captured, it can't go anywhere. Just needs to take up that 3/8 of an inch of the bearing. So I'm going to make it perfect on the outside and inside so it just slips on there. Right now it's just barely a press fit, so I think we'll be okay. But I do need to take half a thou off. Bingo. That's what I was shooting for, right there. Now this is where I hope I don't screw it up. Three-eighths of an inch, and we'll lock the carriage down. You gotta be careful here, Steve-O. Okay, carriage is locked. This is in. Gonna go that way, turn it on. Very gently take that off of there. Bingo. And it gets a little bit of, I'm wondering. It suddenly grabs on it and starts digging in. That I don't like. Let's do something else first here. Afraid to use the power feed. I don't know how far Bob will go down. Just going to see if I can make it go without grabbing in. Ta-da! Come back here. This is where I'm working. This is the outboard rear bearing. There's two of them right there. There's one right there, and one right here. Then you got a labyrinth seal. Well, all I need to do is make the replacement spindle have contact with this back bearing. And it's just this much of that race. It's exactly 3/8 of an inch. And so what I've done to check fit it is put it in here. And getting it perfectly started. Cocked a little. Pardon the noise. Kind of got a winter storm raging outside. I'm trying to get this ring down to a super exact perfect fit. And I can put this ring on the inside of the bearing that it's going to slip into, and it's tight. Too tight. But now that I've taken it off the dadgum, the piece that I cut it out of, getting it perfectly on there and taking out, that's just too much. So what I need to do is either emery cloth it or buff it. Now, I tried some emery cloth, but what I had was too dadgum rough. So I'm going to put a little polishing compound on it. I'm going to turn it in reverse. Now, I just threw this test piece that I made to fit the inside dimension on back into the chuck, and it's not perfect, but I'm just buffing it here. all of the junk off of it around there. Look at that. Ta-da! As you can see, that fit in there without undue force, but it's still pretty tight fitting. I mean, you just can't pull it out with your fingers, but it slid right in there. Swing it around to show you this side. Oh, look what I'm finally getting a chance to try out. It's an Optrel air system for my welding helmet. I'll show you that later. A little wear in that area. There. That's what all the fuss was about. This little 3/8 of an inch was shorter. I think that's going to be fine and dandy. Now all I've got to do is change over the labor seal to this one and then get that tightened up. Didn't have a spanner wrench big enough, so I went and bought one. $50 for a decent American-made one. Williams, USA. But I don't mind paying it. At least it went to somebody here. As you can see, that band went on there pretty easy. It's a good tight fit. And I can't feel any gap right there at all. And I know that this part goes into the inner race of that bearing snugly, so there's no slop there. Now, I had a lot of comments on this video. And I appreciate comments, because that's how you learn stuff. One man says he's a machine tool designer, and that the only way for this to ever work is it to be ground. Put in place and then ground. Well, I've always said 90% of being a machinist is figuring out how to do the work. work holding is a huge part of all of this. If you notice, this thing's hollow. There's no center in here. So to grind this, I would have to have either make a plug for this that fits perfectly and make a perfect center into it. Yeah, it could be done. But even if I did have a center here, I still got to make something for the other side. And then I got to set it up onto a grinder perfectly. Or it's going to start grinding on one side of this spindle and not the other. I mean, it could be done. But frankly, for that little bitty space, you know, the bearing actually goes from here to here. That's 1.5 inches. Can you see? Are you even looking? Come on. Like Dawn. The bearing only goes from right here to here. That's 1.5 inches of bearing surface. It's got 3/4 of an inch of the inboard rear bearing, and then 3/8 of an inch of the outboard rear bearing before it even gets to this spacer sleeve, which I've made as nice a fit as I can. I just don't see it being a problem, and I don't see it worth the risk of putting the center in here and putting it onto the grinder. With that being said, there's also another feature on here that, let me get something here. Now that being said, there's also another feature on here that is missing compared to the original spindle. The original spindle has another one of these, what I consider is a shaft brake or an oil groove, ground into this shaft at 2 1/4, which would be right there. I don't know what the purpose of that would be except to keep oil from running down this way. The diameter on this shaft over here on both sides is exactly the same. Same over here. This just stops right there, and if oil was coming down here, it would stop it from, I don't know. The question is, back to the grinding part. I can put that groove in there. It's square on the bottom. It's not round. So I'd have to dress a wheel to be, a little less than 1/8 wide, and my gosh, not over 50 thousandths deep in this shaft. I have to go through the same everything, make a plug for over here, make something for over there, get it lined up perfect. It doesn't really matter if this is not perfect, except if I grind it too deep on one side, I might as well weld a lug nut on that side. I put a monkey in the wrench. It's not even as it goes around its center of rotation. You have to put a wheel weight on it, just like a tire. With that being said, I'm not going to risk putting that groove in there at this time. If I find that something's screwing up, I can always go back. But right now, I don't think the benefits outweigh the risks. This is one I made before that one. It gets up there, but see how loose that is? This one you could see just slides on there like a glove. Hell, like an O.J. Simpson glove. Tight as hell. Dumb prosecutor. Anyway, that's where I am right now. Thanks for hanging out. Thanks for all the comments. Hi to all the new subscribers. And tell Bob thank you for doing such a nice job on this little ring.